welcome back to my YouTube channel. So this is Sumant. I am here to present you a small introduction about operational amplifier. So this is my second video based on basic electronics. So let's start the video. First of all, introduction to operational amplifier. An operational amplifier is also known as an op-amp. Is a versatile electronic component used in many applications. It is a high gain voltage amplifier with differential inputs and single-ended output. Op-amps are widely used in signal processing, audio amplification, instrumentation, and control systems. You may see in the diagram operational amplifiers are like ideal op-amp. Basic op-amp structures. An op-amp consists of three main components. Two input terminals, non-inverting and inverting, and an output terminal. The differential inputs allow amplification of the voltage difference between the two input terminals. The output is usually connected to feedback circuit to control the gain and other characteristics of an amplifier. So what is a non-inverting amplifier? Ideal op-amp characteristics. In ideal conditions, an op-amp has infinite open loop gain, infinite input impedance, and zero output impedance. The output voltage is directly proportional to the voltage difference between the input terminals. An ideal op-amp has zero offset voltage and infinite bandwidth, meaning it can amplify signals of any frequency. So what is an ideal operational amplifier? In this diagram you may see that V plus is the non-inverting input and V minus is the inverting input, whereas V output is a output, Vs plus is a positive power supply, whereas Vs minus is called as a negative power supply. I think you can visible. So next one is real op-amp characteristics. What do you mean by real op-amp characteristics? Real op-amp have some limitations such as finite gain, infinite impedance, and output impedance. They also exhibit offset voltage, which is a small voltage difference between the input terminals when the input voltage are equal. Bandwidth limitations affect the range of frequencies that can be accurately amplified by the op-amp. What do you mean by ideal op-amp? And the characteristics are gain K is equals to V out, which is infinity. Input impedance Zin is equals to infinity. Input current I is equals to 0. Output impedance Z out is equals to 0. Unlimited bandwidth. Temperature is equals to independent. Inverting amplifier configuration. The inverting amplifier configuration is one of the most common application of an op-amp. It uses negative feedback to control the gain and provides a stable and predictable output. The input signal is connected to the inverting input terminal and the output is obtained from the junction of a resistor and the inverting input terminal. Non-inverting amplifier configuration. The non-inverting amplifier configuration is another widely used application of an op-amp. It provides a positive gain and is often used when a high input impedance is required. The input signal is connected to the non-inverting input terminal and the output is obtained from the output terminal indirectly. Differential amplifier configuration. So the differential amplifier configuration is used to amplify the voltage difference between the two input signals. It is commonly used in instrumentation and communication systems to amplify weak signals and reject the common mode noise. The output is obtained from the output terminal and the inputs are connected to the inverting and non-inverting input terminals. You may see the diagram, V1 is connected to R1 and the V2 is connected to R2 through RF and RG. And the next topic, applications of operational amplifier. Op-amps are widely used in audio amplification, active filters, oscillators, voltage regulators, and analog to digital converters. They are essentially components in feedback control systems, providing stability and precision. Op-amps are also used in instrumentation for signal conduction, amplification and measurement. What are the applications of op-amp? You may see in the diagrams. So thank you friends. So please like and subscribe.